Namaste my dear students, నేను మీ సూర్యతేజ ఫ్రమ్ సాయిమేధ ఈసెట్ కోచింగ్ సెంటర్ కోటి హైదరాబాద్. డైరెక్టర్ జేసీ సార్ ఆధ్వర్యంలో శశికాంత్ వాల్మీకి సార్ పర్యవేక్షణ నిర్వహిస్తున్న సాయిమేధ కోచింగ్ సెంటర్ కోటి హైదరాబాద్ ఈసెట్ 2023 రాసిన విద్యార్థులందరికీ మీరు అబ్జెక్షన్స్ పెట్టుకోనికి వీలుగా ఉండాలి అనే ఉద్దేశంతో ఈసెట్ పేపర్స్ అన్నిటిని బిట్ టు బిట్ ఎక్స్ప్లెయిన్ చేయడానికి ఈ వీడియో లెక్చర్ సిరీస్ మీ ముందుకు తీసుకురావడం జరిగింది. కాబట్టి మై డియర్ స్టూడెంట్స్, ఎవరైతే ఈసెట్ 2023 రాస్తారో, ఎవరైతే క్వశ్చన్స్కి ఆన్సర్స్ తెలుసుకోవాలనుకుంటున్నారో, పూర్తి డీటెయిల్ ఎక్స్ప్లెనేషన్ ఈ వీడియో లెక్చర్స్ని ఖచ్చితంగా వాచ్ చేయండి. అలాగే మీ ఫ్రెండ్స్ అందరికీ కూడా ఈ వీడియో లెక్చర్ సిరీస్ని షేర్ చేయండి. దీంతో పాటుగా మై డియర్ స్టూడెంట్స్, ఎవరైతే ఈసెట్ 2023 రాస్తారో వీళ్ళందరికీ సాయిమేధ కోచింగ్ సెంటర్ కోటి హైదరాబాద్ ఒక ద్రోణాచార్య బ్యాచ్ ని ఇంట్రడ్యూస్ చేసింది. గత 25 సంవత్సరాలుగా ఎంతో మంది ఇంజనీర్లు తయారు చేసిన సంస్థ సాయిమేధ కోచింగ్ సెంటర్ కోటి హైదరాబాద్ డిప్లొమా విద్యార్థులకి అండగా బాసటగా నిలవన ఉద్దేశంతో ఈ బ్యాచ్ ని మీ ముందుకు తీసుకురావడం జరిగింది. ఈ బ్యాచ్ లో భాగంగా మీ అందరికీ మొదటిగా మీరు బీటెక్ లోకి వెళ్ళిన వెంటనే ఇబ్బంది పడుతారు అనే ఉద్దేశంతో, ఆ ఇబ్బందిని పోగొడితేనే ఫ్రీ మైండ్ తో ఉంటేనే పని బాగా చేస్తారనే ఉద్దేశంతో బీటెక్ 2-1 అకాడమిక్ సబ్జెక్ట్స్ ని ప్రొవైడ్ చేస్తున్నాం. బీటెక్ 2-1 అకాడమిక్ సబ్జెక్ట్సే కాకుండా సిఆర్టీ క్యాంపస్ రిక్రూట్మెంట్ ట్రైనింగ్, దీనిలో భాగంగా ఆప్టిట్యూడ్, రీజనింగ్, ఇంగ్లీష్, అదేవిధంగా సిఆర్టీకి కావాల్సిన బేసిక్ కోడింగ్ లాంగ్వేజెస్ సి కావచ్చు, C++ కావచ్చు, జావా కావచ్చు, పైథాన్ కావచ్చు, వీటన్నిటిని మనము లైవ్ క్లాసెస్ ద్వారా అందిస్తాం. దీంతో పాటుగా థర్డ్ వన్ డిప్లొమా బేస్డ్ జాబ్స్ టెస్ట్ సిరీస్, మీరందరూ సంవత్సరం నుంచి కావచ్చు, సెకండ్ ఇయర్ కంప్లీట్ అయిన దగ్గర కావచ్చు, ఫస్ట్ ఇయర్ కంప్లీట్ అయిన దగ్గర కావచ్చు, ఈ సెట్ కొరకు ఇంజనీరింగ్ సబ్జెక్ట్స్ బాగా ప్రిపేర్ అయ్యారు. ఇదే ఇంజనీరింగ్ సబ్జెక్ట్స్ అనేది మీకు రేపు డిప్లొమా బేస్డ్ జాబ్స్ కూడా ఉండడం జరుగుతుంది. కాకపోతే మీరు రేపు జాబ్ పడినప్పుడు రెడీగా ఉండాలంటే కన్సిస్టెంట్గా ప్రిపరేషన్ అది అవసరం అవడం జరుగుతుంది. కన్సిస్టెంట్గా మీరు ఆల్రెడీ మీ అందరూ బాగా ప్రిపేర్ అయ్యారు, మీకు సపోర్ట్ ఉండాలనే ఉద్దేశంతో ఒక టెస్ట్ సిరీస్ కూడా మనం ద్రోణాచార్య బ్యాచ్లో ఇంక్లూడ్ చేయడం జరిగింది. ఈ టెస్ట్ సిరీస్లో భాగంగా ప్రతి వీక్ టాపిక్ వైజ్ గ్రాండ్ టెస్ట్లు కండక్ట్ చేస్తాం. టాపిక్ వైజ్ అయిపోయిన తర్వాత మనం మిక్స్డ్ టాపిక్స్ ఆర్ మిక్స్డ్ సబ్జెక్ట్స్ గ్రాండ్ టెస్ట్ కండక్ట్ చేస్తాం. ఫైనల్ గా ఓవరాల్ గ్రాండ్ టెస్ట్లు కండక్ట్ చేయడం జరుగుతుంది. 1 ఇయర్ పాటుగా మీకు ఈ డిప్లొమా బేస్డ్ జాబ్స్ యొక్క టెస్ట్ సిరీస్ కోర్స్ అందించడం జరుగుతుంది. దీంతో పాటుగా 2 ఇయర్స్ వ్యాలిడిటీతో ఆల్ ఓవర్ ఇండియాలో ఎవరు తయారు చేయలేని విధంగా మన సాయిమేధ కోచింగ్ సెంటర్ కోటి హైదరాబాద్ ఒక గేట్ కోర్స్ని రెడీ చేయడం జరిగింది. ఆ గేట్ కోర్స్ విత్ వ్యాలిడిటీ ఆఫ్ 2 ఇయర్స్ అందించడం జరుగుతుంది. ఈ 4 మాడ్యూల్స్ మనము ద్రోణాచార్య బ్యాచ్లో అందించడం జరుగుతుంది. దీని విలువ సుమారుగా ₹1,00,000. కానీ ఈ కోర్సు మొత్తాన్ని ఫ్రీ ఆఫ్ కాస్ట్గా అందించడం జరుగుతుంది. జస్ట్ ఈ 2 సంవత్సరాల మెయింటెనెన్స్కి, అదేవిధంగా టెస్ట్ సిరీస్ కోసమని రిజిస్ట్రేషన్ ఫీజ్ ₹3,000 అనేది తీసుకోవడం జరుగుతుంది. ఎవరైతే డిప్లొమా కంప్లీట్ చేసుకుని బీటెక్ వెళ్తున్నారో వీళ్ళందరికీ ఒక మంచి అవకాశం ఇది. కాబట్టి ఈ అవకాశాన్ని మీరందరూ ఉపయోగించుకుంటారని ఆశిస్తున్నా. మీరు ఈ అవకాశాన్ని వినియోగించుకోవాలంటే ముందుగా మీరు మన అప్లికేషన్ స్పేస్ గేట్ అనే అప్లికేషన్ని డౌన్లోడ్ చేయండి. డౌన్లోడ్ చేసిన తర్వాత అందులో ప్రొఫైల్ సెక్షన్ ఉంటుంది. ఆ ప్రొఫైల్ సెక్షన్ మొత్తాన్ని ఫిల్ చేయండి. ఫిల్ చేసిన తర్వాత మీ అడ్మిషన్ ప్రాసెస్ కోసమని 9848692598 ఈ నెంబర్కి కాంటాక్ట్ అవ్వండి. అడ్మిషన్ ప్రాసెస్ ఎట్లా, అదేవిధంగా ఇంకేమైనా కోర్స్ డీటెయిల్స్ ఏమైనా కావాలంటే కూడా పూర్తి ఇన్ఫర్మేషన్ అందించడం జరుగుతుంది. మై డియర్ స్టూడెంట్స్, మీరందరూ ఈ అవకాశాన్ని వినియోగించుకుంటారని ఆశిస్తూ నేను మీ సూర్యతేజ ఫ్రమ్ సాయిమేధ ఈసెట్ కోచింగ్ సెంటర్ కోటి హైదరాబాద్.
Question number 23. The question is a 5 kVA 2000 upon 400 volts 58 single phase transformer gave the following test result. Open circuit test, the 200 volts 0.7 amps 60 watts on low voltage side. The short circuit test, the 22 volts and the 20 amps 16 amps 120 watts on high voltage side. Now determine the load per maximum efficiency. Option 1, the 4.52 kVA. Option 2, 3.52 kVA. Option 3, 5.52 kVA. Option 4, 2.52 kVA. So in this case, here mention that open circuit test conducted at rated voltage condition. So conducted on low voltage side. Normally open circuit test is conducted on the low voltage side of the transformer at rated voltage. So this rated voltage is mentioned here, and so that these are the total iron losses of the transformer. So this iron loss is equal to 60 watts. Now let us find the, suppose short circuit test conducted on high voltage side normally at rated current condition. So I rated the refer to the HV side of the transformer, high voltage side. So how do we get high voltage side? This is a 5 into 10 to the power of 3 divided by, so this one is a 400 volts. So now 5000 divided by 400 volts, so that is a 12.5 amps. Now this is the 12.5 at this condition. Now we required this copper loss. It's not a, this is the copper loss but not full load copper losses. We required full load copper losses. So how do we find out full load copper loss? The full load copper loss, okay, that is we need to find out the copper losses at this current. So copper loss is a directly proportional to square of the current. So therefore copper loss, okay, at the 12.5 amps is equal to, so this is the 120, the under 120, the into, so this one is the 12.5 divided by the 16 square. Now this value is equal to, so it is a 25. So this one is this value is equal to, so 25 copper losses is a, so now this is a, let's calculate. So 12.5, it is equal to 25 amps. Okay. So by solving this you can get, so 25 amps. Yes, it's not 25, it is a 73.24 watts, 73.24 watts. Now we required KVA rating. How do we get the KVA rating? So this KVA, okay, at maximum efficiency condition, so now value is equal to rated KVA, the into rated KVA and multiplied by, so iron losses divided by full load copper losses. Now this is equal to rated KVA is the 5 KVA, the multiplied by, so iron losses is equal to 60 watts divided by 73.24 watts. So by solving this we can get 4.52 KVA. So answer for this question, option 1 is a correct. And next one, question number 124. The HV terminals of the 3-phase bank of 3 single phase transformer connected to the 3-wire 3-phase 11 kV line, the line to line system, and the LV terminals are connected to the 3-wire 3-phase load of 1000 kVA 220 volts. Find the KVA rating of the LV terminal of the each, okay, LV terminals of the each transformer for star delta connection. So these are the options for this question. So we have a 3-phase transformer, okay, this is the 3-phase transformer. Now this is the input side, okay, this one is the input, is a 3-phase supply. This supply side is a LV, okay, this one is the LV side of the HV side is connected. And here also mentioned the load is a connected. So this load power, so this is the load power is equal to output power, so that is a 1000 kVA, okay, this is the 1000. So now this is the kVA of, okay, kVA rating of the 3-phase transformer, okay, kVA rating of the 3-phase transformer. Now this one is the kVA, but we require the KVA rating of, okay, single phase transformer. The single phase transformer, the is equal to the KVA rating of 3-phase transformer divided by how many number of the 3 single phase, how many number of single phase transformer required to design the 3-phase transformer. So 3 single phase transformers are required. So therefore 1000 the KVA divided by 3. So it is equal to 333.33 kVA. So answer here 333.33 kVA Option 2 is correct. Okay. And next one, the question number 125. The short circuit test on a transformer gives its equivalent resistance and core losses. Okay, it is not correct. And magnetizing impedance, it is also not correct. The equivalent resistance and reactance. Okay, this is the correct option. Magnetizing current and the core losses. So what are the objective of the short circuit test? This test it is conducted to find out the copper losses, to find out the series branch parameters of equivalent circuit, such as the resistance referred to the total resistance referred to the primary side and total reactance referred to the primary side, and also in order to find out per unit study short circuit current, to find out percentage resistance, percentage reactance and percentage impedance of the transformer. So in this question, in this option mention that equivalent resistance and reactance of the transformer.
A series RLC circuit will have unity power factor if operated at frequency of, look at here, series RLC circuit is saying, right? So if you just look at that phasor diagram, what you can comment? Okay. So current is a reference phasor because all the elements are connected in series, carries same current. But here if you talk about voltage across the resistor is in same phase, and voltage across the inductor will be leading and voltage across the capacitor will be lagging with respect to current. So when we get supply voltage is in same phase with what current, when VL is equal to VC. Okay, when VL is equal to VC, what will happen? V is equal to VR, and V and I are in same phase. V and I are in same phase means phase angle difference is how much here? Phase angle difference is 0. So phi is equal to 0. Then what will be the power factor? Power factor cos phi is equal to 1. So whenever voltage current both are in same phase, so when VL is equal to VC means circuit is under what? Resonance. When circuit is under resonance only we can have this. So what will be the result when VL is equal to VC? VL is equal to VC means I into XL is equal to I into XC, same current. So XL means omega L, XC means 1 by omega C. From here omega square is equal to 1 by LC, omega is equal to 1 by root LC. So F is equal to 1 by 2 pi root LC at this frequency. So this is in radians per second and this is in what cycles per second, frequency is in what? Hertz. So these are the what, like this is the what frequency at which, so what we call this resonant frequency. At this frequency only unity power factor we achieve. So fourth option will be the what correct option here for the question, right? Next one, if you see, a coil draws 0.5 amperes from a 120 volts 60 hertz source at 0.8 lagging power factor. What are the coil resistance and inductive reactance? If you see that coil means definitely resistance will be there and reactance will be there. He is talking about both R and what XL, these values only, and both values he is asking. And if you see that excitation is how much here this time? 120 volts, right? 120 volts comma 60 hertz is there, and it is carrying current how much? 0.5 amperes. So power factor is also specified. What is that? 0.8 lagging. Lagging only will be there because it is a coil. Let us look into this. We know that, right? We know the voltage, supply voltage is 120 volts and the current which is carrying is what? 0.5 amperes. So I can find the impedance offered by the magnitude of impedance means V by I. So how much we get? 120 by 5 by 10 we get. So if you simplify here, so 1200 by 5. So how much we get? 5 2s means 254 means 240 ohms we get. This will be the magnitude of impedance, right? Magnitude of impedance we got, right? And one more thing, it is a coil. So what is the impedance here? Z is equal to R plus J XL. So here impedance triangle, if I draw R and this is what J XL, and this will be the what magnitude of impedance, and this phase angle is phi. So power factor is given cos phi is equal to, what will be the cos phi from the right angle triangle? R by Z only, right or not? So cos phi is given as what? 0.8. Resistance you can find because impedance magnitude you know how much it is, 240. So if you simplify from here, R is equal to 240 into 0.8. So resistance is equal to how much? We get 192 ohms. So once you know this resistance, how to find the other one? Because we know the magnitude of the impedance, so Z is equal to square root of R square plus X square. Now 240 is equal to square root of R, we got 192 square plus this is XL square. From here if you simplify, XL is nothing but square root of 240 square minus 192 square. If you do this, we get XL is equal to 144 ohms. So both resistance and inductive reactance we obtained here from this. Simple one, okay, series RL circuit. If you know this impedance triangle, right angle triangle information, you can easily answer such questions. Okay, simple question, but you need to have that idea, power factor, how you are taking from the right angle triangle. Okay. So next question, if you see, observe here, an impedance is having what, how much resistance as well as what inductive reactance, 2 plus J80 means we take like this. Source having what, an angular frequency of, how much frequency? 1200 radians per second. What element should be connected in parallel to the impedance Z? This is what Z. To get that current drawn from the source is in same phase with what? Current and voltage should be in same phase, means definitely to have that voltage and current are in phase, are in same phase, means phase angle must be 0, means unity power factor. Definitely circuit is under resonance. For occurrence of resonance, definitely L and C must be there. Here already inductance is there, so definitely here we should connect a capacitive element. So capacitance must be connected here. Got the point? So simple question, okay, again resonant related question. So capacitance must be there. For having resonance, both inductor and capacitor should present. So whenever net reactance is 0, if it is impedance, net reactance is 0. If it is admittance, net susceptance is 0. Then we can achieve the what, resonance condition. First one is in the case of impedance, second one is in the case of what, admittance. So resonance related question only. Next one, if you see, look at here, how much power is absorbed by the circuit that has an input impedance, sorry, not impedance, admittance of, what is admittance here? 0.3 plus J 0.4 Siemens or Mohs, Siemens or Mohs, and carries a current of what, 30 ampere. How much power is absorbed by the circuit? How much power is absorbed by the circuit means what we need to do here. So power absorbed means that must be what, active power. Active power, how you can write here? It is like I square into R. R you can even indicate in the form of V square into G. But here current is given, admittance is given. Admittance means what is this form? G plus JB is there. But if I have the impedance, so I should convert this into impedance, that is equal to R plus or minus Jx like this. So then I can use this resistance and I will get the what result. So if I convert this, what will be the thing we get? How to get impedance from this? Impedance is what? Reciprocal of admittance. So 1 by 0.3 plus j 0.4. So if you go with the rationalization process, multiply with 0.3 minus j 0.4 by 0.3 minus j 0.4. So what we get if you simplify? So 0.3 by 0.3 minus j 0.4 by a plus b into a minus b means a square minus b square, but j square means minus, minus of minus becomes what? Plus. So we get 0.3 whole square plus 0.4 whole square. If you simplify, z becomes what? 0.3 minus j 0.4 by 0.25 we get. This will be what in terms of ohms. Now I can use this active power means power absorbed means that must be active, right? So I square means 30 square into resistance means this part only we need to take 0.3 by 0.25. So simplify here 30 into 30 into 0.3 by what we get 0.25. So if you simplify here, how much we get? 900, okay, or 90 into how much we get? 900 into 3 by 2.5. So if you simplify, what will be the result we get? Right? 900 into, right, 900 into 3, right, divided by 2.5. We get what? 1080 watts. But here answer is not available. They had given 540, but here it should be actually 1080 must be there. Or you can even do by finding voltage, then go with the conductance, directly multiply with this. Also you will get the same answer. So this will be the change you need to focus for this question. 1080 is not available, but some calculation part is missing by the examiner, okay, right? So definitely answer must be 1080 only. So this will be the answer.
Question number 130. This question belongs to the transformer part. The transformer will operate at maximum efficiency when hysteresis loss equal to eddy current loss equal to copper losses are equal to iron losses, the hysteresis loss equal to copper losses. So maximum efficiency occurs when variable losses are equal to constant losses, where variable losses are copper losses and constant losses are iron losses of the machine. So that copper loss equal to iron losses. So option 3 is correct for this question. And next question number 131. The transformer are rated in kVA instead of the kilowatts because, so load power factor often not known. The kVA is a fixed where kW depends on the load power factor. The total transformer loss depends on the volt ampere. It has become customer. So now this one is a kVA rating of the transformer that depends on the temperature rise. That means the losses of the transformer. Majorly we have two types of the loss in the transformer. One is a copper losses and iron losses. The iron loss measured in the volts, whereas copper losses measured iron losses represent the voltage parameters. So and copper loss depends on the current parameters. The iron loss depends on the voltage, whereas copper loss depends on the current. So volt amperes. So that's the transformer loss depends on the volt amperes. So option 3 is correct for this question. And next question number 132. The synchronous reactance of the alternator is due to the leakage flux as well as armature flux, and the leakage flux only. The reactance because of armature reaction of the machine, the synchronous machine reactance. Okay. Now synchronous reactance excess, it is a sum of the reactance excess value is equal to the here excess is equal to the XL, the plus okay XA all. The XL is the reactance corresponding to the leakage flux. Okay, this is the reactance corresponding to the due to pi L. So now this one is the reactance corresponding to armature reaction. So synchronous reactance is the sum of the leakage reactance and reactance corresponding to armature reaction. So option 1 is correct for this question. And next one, let us solve question number 133. The power input of the 415 6-pole 3-phase induction motor, the running at 975 rpm, the at 40 kilowatts, the stator losses are 1 kilowatts, frictional and windage losses the 2 kilowatts, the efficiency of the motor around. The option, these are options for this question. So mention that power input of the induction motor, power input of the induction motor, so that is equal to 40 kilowatts. Okay, now power output of the power, it is also called, so this is the power input here. So stator output power, so this stator output power, or it is also called the rotor input power or air gap power. So this one is the power in rotor input power here. So this is equal to the input power of the machine minus stator losses. So what are the stator losses? The stator losses is equal to 1 kilowatts. The input power is a 40 kilowatts minus 1 kilowatt, that is equal to 39 kilowatts. So after getting the rotor input, so let us find out gross mechanical power output. Okay, this gross mechanical, the power output of the motor. So how do we get gross mechanical power output of the motor? So this one is a 1 minus S times of, so now this one is the 1 minus S times of the rotor, the input power of the machine, where S is equal to, okay, this is the slip of the motor. So it is the Ns minus N by the Ns value. The N is given 975 rpm. So now this value, okay, how do we get the S value here? The S is equal to, so we can find the 6-pole, consider 50 Hz frequency. So Ns is equal to 120 F by the P. So now it is equal to 120 the into 50 Hz by the 6-pole, that is equal to 1000 rpm. So if frequency is not mentioned, consider 50, F is equal to 50 Hz. So therefore S is equal to the 1000 minus 975 the divided by the 1000 rpm. So it is equal to 0.025. Okay, this one is the 0. So that is a 0.025. So now after getting S, so we can find out the gross mechanical power output. The gross mechanical, the power output of the motor. So it is equal to 1 minus S into the rotor input power. So this value is equal to 1 minus S into the rotor input power. So it is equal to 1 minus 0.025 the multiplied by, so this one is rotor input is a 39 the kilowatts. Now this is equal to 0.975 the into 39 the kilowatts. Got it? So now this is the rotor gross mechanical power. Now we required net mechanical power output. How do we get the net mechanical? The power output of the machine. So that is equal to gross mechanical power output, Pg, the minus the mechanical losses. Okay, mechanical loss. So it is equal to 0.975 into 39 kilowatts minus, okay, how many the mechanical losses are there here? 2 kilowatts. Okay, these are the mechanical loss. Now we required efficiency of the motor. So how do we get the efficiency? The net mechanical power output divided by input power, the multiplied by 100. So percentage efficiency is equal to the 0.975 into 39 kilowatts, the minus 2 kilowatts, the divided by the 40 kilowatts. So into 100. So by solving this, so approximately you can get the 90% efficiency. So answer for this question, the 90%, option 2 is correct for this question. Got it? So next question number 134. For a synchronous machines, the which one of the following statement is false? So in salient machines, the direct axis reactance is greater than the quadrature axis reactance. It is a correct statement. The damper, the bars, the help with the synchronous motor self starting. The short circuit ratio is a ratio of the field current required to produce the rated voltage, and open circuit the at rated open circuit terminal short circuit condition. So V curves of the representation armature current and field. So this is the correct statement, and this so these two are also correct statement. Now actually SCR, short circuit ratio, is the field current at the rated voltage. This is the field current required to produce the rated voltage under open circuit, at rated voltage under the open circuit condition. And next one, divided by field current at rated current. This rated current, the under the short circuit condition. This is the short circuit ratio. So now answer for this question, option 3 is a wrong statement. Option 3 is a correct. Actually the field current, it is the ratio of field current required to produce the rated voltage under open circuit to the field current required to produce the rated current under short circuit condition. So that is a SCR, short circuit ratio. And next one, question number 135. In a single phase induction motor driving a fan load, the reason for the having high resistance of the rotor to achieve the low starting torque, high efficiency, quick acceleration and reduced size. So now here this one is single phase induction motor. The high resistance increases the starting torque of the machine, so that it is a quick acceleration. Starting torque is directly proportional to the rotor resistance. So now as the rotor resistance increases, starting torque increases, so that is a quick acceleration of the motors. So option 2 is correct for this question. And next one, question number 136. A 3-phase synchronous motor connected to the infinity bus bar with a constant excitation is driving the constant load. The operating at leading power factor. So if the shaft is reduced, this one shaft is reduced. So now in this case the load angle will increase, the power factor will increase, and the power, this load angle will decrease, and power is no change in the load, no change will occurs. Suppose this one is the terminal voltage Vt, and in this region mechanical input is excitation is a constant. The excitation is constant, and mechanical input is, so this mechanical input is mechanical output of the motor is varied. So when mechanical output is varied, suppose this is the reason. So now here the leading power factor side, the Ia, so now leading, and next this one is the excitation induced EMF E values. So when it is operated at leading power factor side, so this angle is this is a theta, so this one is a delta. Suppose if I take another mechanical load, suppose Ia1 and Ia2, so now this delta value here, so this one is a E, the E2 here. So now this delta 1 and the delta 2 here. So assume initially it is operated at condition 2. Then if mechanical load is reduced, then what will happen? So as mechanical load, this mechanical load is reduced, then what will happen? So this is the delta 2, delta 1, so is less as compared to the, so initially at delta 2, this delta 2 condition. So now here delta 1 is a less as compared to the delta 2 here. So mechanical load is reduced, the load angle will be reduced. Delta is called as a load angle. So that option for this question, option 2 is a correct. Got it? And next one, question number the 137. A single phase 2000 volts alternator has armature resistance of and reactance of 0.8 ohms and 4.94 ohms respectively. The voltage regulation of the alternator for a load of 100 amps at 0.8 power factor leading. So, what is the percentage voltage regulation? Percentage voltage regulation of alternator the is equal to the V minus VT divided by no load voltage minus full load voltage by the full load voltage multiplied by hundreds. Okay, this is the pump. So, VT is given. So, this is the terminal voltage, the VT, the single phase. So, that is why phase voltage it is equal. For leading power factor, how do we get this V value? So, for the leading power factors, okay, this leading power factor, the magnitude of the E is equal to under root of VT cos theta plus the IA RA whole square the plus VT sin theta minus IA XS whole square. So, this is for the magnitude of the induced EMF or no load voltage per leading power factors. Now, let us substitute E is equal to, where E is equal to under root of this one is the VT cos theta. VT is at 2000 the into 0.8, cos theta is equal to 0.8. So, now the plus IA is equal to load current is equal to 100 amps multiplied by 0.8. So, this whole square the plus and VT sin theta. So, VT sin theta means 2000. If cos theta is equal to 0.8, sin theta will become 0.6. So, minus IA is equal to 100. So, 4.94, okay, this is a whole square. Now, by solving this, magnitude of induced EMF is equal to, so this one is under root of the 1680 square minus 706 square. Now, this value is equal to, by solving this, so now it is a 1822, nearly 1822 volts. Okay. So, I will tell you exact answer for this question. So, 1822 point, okay, this one is the 316 volts, okay, this one is the E1. So, now let us calculate the voltage regulation. The voltage regulation is equal to, percentage voltage regulation is equal to the E minus VT by the VT multiplied by 100. So, what is the value of E? Where E is equal to the 1822.316 minus 2000 divided by 2000, so multiplied by 100. So, by solving this, minus 8.88%. So, this answer for this question minus 8.88%. So, here also no options are matching. Okay, these no options are matching for this question. So, that we can challenge for the answer. Okay. So, objection we can do the objection for this question. So, actual answer is the minus 18.88%. Suppose nearer answer is a 7% is the right comparatively, but in the given option is a minus 11.62, it is not correct. So, exact answer is a minus 8.88%. Clear my point?